Hello everyone, welcome to Sri Chaitanya Academy, and I also welcome you to this special session of transition course where we are going to discuss about the next part in our journey of chemistry, where we will discuss about mole concept. Now this mole concept is a fundamental concept which will be applicable in many, or I'll tell you most of the chapters of physical chemistry and inorganic chemistry, and some chapters of even organic chemistry. So pay a lot of attention to this mole concept. Right. So the mole concept, 1 minute, let us get this. Right. So mole concept is made essentially from the word mole, correct? So let us understand what is mole. So normally if you see in books, they will tell you that 1 mole equals 6.023 into 10 raised to power 23 atoms, ions or molecules or particles or entities, right? See, mole is not an alien concept. We also in our day-to-day lives use something similar to moles, that is dozen. And mole is called a chemist's dozen. Why is it called a chemist's dozen? Because the way in your day-to-day life, if you go to the market and try to get a dozen eggs, right? How many eggs will be there in a dozen? 12 eggs, right? So a dozen is made up of 12 eggs. A pair, if you have a pair of socks, a pair is made up of 2 socks. So this is just a way of naming a collection of objects, right? Now, a mole is a collection of how many objects? 6.023 into 10 raised to power 23 objects, right? This can be, if I talk about and ask you how many eggs are there in 1 mole of eggs? Well, you will say 6.023 into 10 raised to power 23 eggs are there in 1 mole of eggs, right? So that is why 1 mole is called a chemist's dozen. Now moving on to the actual definition, right? It says that mole is the amount of a substance containing the same number of elementary chemical units. Elementary chemical units, right, as number of atoms present in 12 grams of carbon 12 isotope. So let me break this definition down for you, right? 1 mole is equals to number of particles which is equals to number of atoms in 12 grams of carbon 12. So somehow if I am able to find the number of atoms in 12 grams of carbon 12, that will give me the value of 1 mole. Is this clear from this definition? Mole is the amount of substance. It is amount of substance which contains the same number of particles as there are number of atoms in carbon 12, right? Now, now to move forward, let me link this to our day-to-day lives. Suppose you have 100 kg of rice. And in the shop, each bag of rice, right? So 1 bag of rice has 10 kg rice. So each bag can carry 10 kg of rice. So can you tell me how many bags you can make out of it? How many bags you can make out of it? Well, simply what we do is we divide this 100 by 10 and we'll get 10 bags. Right? So each bag is a mole. So now in this way, if I say, tell me how many atoms are present in 12 grams of carbon. So what we did was, if you carefully see, we did the total weight, we divided the total weight by mass of one bag, right? Right. So let me take one more slide, okay, and make things easier for you. So let us get back. We wanted the number of atoms, so we wanted the number of bags or number of particles. For that, at the end, I told you will have total weight divided by mass of one bag, right? The same ideology or the same logic will follow here. What I'll do is, so you have like number of bags was equals to total mass by mass of each bag, right? Similarly, number of carbon 12 atoms will be equals to the mass. Which mass? 12 gram mass, right? So 12 gram mass divided by mass of each carbon 12 atom. Or if you don't want each, you can use one carbon 12 atom. So what is the mass of one carbon 12 atom? That was found as 1.99 into 10 raised to power minus 23 grams. So if you do this division, right, something magical happens if you do this division. What happens? This value, you can see minus 23. This minus 23 will go in the numerator and will become plus 23. And this value comes out to be, see, this is approximately what? 1.9 is approximately 2, right? It is approximately 2. 2 divided by 12, you can cut it by what? 6. So you'll get approximately 6, but we have to be exact. 6.023 into 10 raised to power 23. What is this? These are atoms of carbon 12. So these many atoms are present. Let me take. So these many atoms are present. Atoms are present in 12 grams of carbon 12, and no surprises here. This value is exactly same as what? 6.023 10 raised to power 23. So this is the origin and the original calculation through which mole was calculated. So after we have done this, 1 minute. After we have finished with this, this number 6.022, somewhere in some books it's 6.022, somewhere it is 6.023, doesn't make much of a difference. I will normally use 6.023. This number is represented by this letter N subscript A. A capital N, and below it you will write capital A. This is called Avogadro's number. Okay, this particular number. So whenever anywhere Na is written, that is your indication that I'm talking about 6.023 into 10 raised to power 23. Okay, anything, this is this value. Now let us talk about something called, first I'll talk about molar mass or molecular mass. So if I ask you what is molar mass, so the first thing that will come to your mind, maybe molar mass is what? What is molar mass? It can be mass of 1 mole of a substance. Mass of 1 mole of a substance. Okay. So if you have, suppose I've taken this as an example, if you have water. So water has molecules like this. If I take 6.023 to 10 raised to power 23 molecules of water in my hand and place them here on the weighing balance, the weight I will get is around 18 grams. This 18 grams is called the molar mass of water, right? It's called the molar mass of water. This molar mass sometimes is also called as molecular mass. Don't get confused. It's the same. And this was mass of 1 mole molecules. Now instead of that, if I have atoms like oxygen atoms, 6.023 into 10 raised to power 23 oxygen atoms, then mass of those 6.023 to 10 raised to power 29 oxygen atoms. Yes, hi Vikas, thanks for commenting, right? If you have any doubts, you can write down in the comment section, right? Okay, right. So mass of 1 mole atoms is called atomic mass. So if I have 6.023 atoms of oxygen and that I'm going to weigh on the weighing balance, then whatever mass I'm getting, that will be the atomic mass. Okay. Now another comparison, that's what I said. 1 mole of oxygen atoms has a mass of 16 grams. 1 mole of oxygen molecules, remember oxygen's atomic number is how much? It is 8. So the mass number is 16. So normally you will find that the mass number and mostly it will be equal to like this, and here this 18 is the mass number of oxygen, right? 1 mole of nitrogen 28 grams, right? 1 nitrogen is 7, right? 2 sevens, 2 multiplied by 7 becomes 14, so you'll get 14 grams here. And nitrogen molecule has N2, 2 nitrogens, so double this, you'll get the mass of, molar mass of nitrogen molecule. Understand that I'm talking about this here, but here I'm talking about double of this, right? That's why you can see the values are exactly doubled. Now again, there is a chart here. 1 mole of oxygen means these many atoms of oxygen. 1 mole of oxygen molecules means these many molecules of oxygen, means O2. And 1 mole of oxygen molecules will have how many oxygen atoms? Let me repeat myself. 1 mole of oxygen molecules will have how many oxygen atoms? See, 1 oxygen molecule has 2 oxygen atoms, right? So if you have 1 mole of oxygen molecules means Na multiplied by O2. Both sides if you do, you'll get Na multiplied by 2 into O, right? So that is what is written here, 2 Na. So Na is this is 2, right? So mole concept in ionic compounds. Now this mole concept is a little different in ionic compounds, okay? So amount of ionic compound is simple. If ionic compound has a formula, according to that formula, Whatever mass you can get, that is the molar mass of that ionic compound. So sodium is around 23, right? Chlorine is around 35.5. You add them, 58.5 you are getting. So that is the molar mass. So this means what? You have 6.023 into 10 raised to the power 23 units, formula units of NaCl. And it also means, see, each formula has Na plus 1 Na plus and 1 Cl minus, correct? 1 Na plus and 1 Cl minus. If there is one NaCl molecule here, it will give you 1 Na plus ion and 1 Cl minus ion. In the same way, okay, this is a little tricky concept. Let me just explain it properly. Right. So if you have one, suppose, molecule of NaCl, this one molecule of NaCl will have 1 Na plus, correct? And it will have 1 Cl minus. Now, if I want to make it into 1 mole, means Na should be there. So multiply both sides by Na. If you do that, you get Na molecules of NaCl. This will be equals to capital Na, right? Ions of Na plus or Na ions of Cl minus, right? That is what is written here. So by now, if I say mole, in your mind you should visualize it that it means 6.023 into 10 raised to the power 23 atoms, eggs, tomatoes or onions, right? The same thing with Na2SO4. Right? Here in 1 mole you have 2 sodiums, so that's why there is a 2 here. SO4 minus is 1, so you have 1 here, and this is the molar mass. Now in the next few sessions we will learn calculation of moles from various things that are given to you. Okay? First is mass. So let us recall what is molar mass. Molar mass is mass of 1 mole of substance, right? 1 mole of substance means mass of 6.023 into 10 raised to power 23, right? Atoms, ions or molecules. Now suppose I tell you that I have 4 moles of water. Right. Can you think of a way to calculate the mass of this 4 moles of water? And I will also give you that molar mass of water is 18 grams per mole. Remember, the unit of molar mass is supposed to be 18 grams per mole. This per mole is important. If you do not have it, you will get to know in future what problems you will encounter, right? So molar mass of water has to be, or any molar mass for that matter, you need per mole there, right? So molar mass is essentially mass of 1 mole. So mass of 1 mole you know. So what will be the mass of 4 moles? Mass of 4 moles will be 4 into 18 grams per mole, right? So you'll get around 72 grams, right? Now focus your attention on this last thing what I have done. From this you can get this formula easily. So this is the total mass. Mass of 4 moles is actually what? Okay. If this is understood, let me take one more slide here. So mass of 4 moles. So I will write that as your total mass. Here 4 was number of moles. So that will be your number of moles. You multiply that with what? This was molar mass. Right? So from this, can we get the formula of number of moles? Yes, we can. Number of moles will be, take this to that side, you will get again your total mass by molar mass. Right? This formula is the same as this. So moles is represented by the small letter n, right? Molar mass is represented by a capital letter M, yes, right? And given mass is G. Now, stay with me on this one. Per mole. Yes, you can get in NIT, Computer Science and Engineering. Wait for the counseling, Pranshu. Right. So why I told you gram per mole? See, mass is in grams. Molar mass should be in gram per mole, because if it is not, so here grams can cancel out. This mole inverse goes above and you get the answer in. That's why this mole inverse is important. And this is the first fundamental formula to get moles. Okay? Now, moles of atoms, again nothing, given mass by atomic mass. Moles of molecules, given mass divided by molecular mass. These are all the most basic formula for moles. And this is how you get it, right? So now let us move forward. Important formulae in the mole concept. 1 mole of atoms. If they talk about any time 1 mole of atoms, it will be mass of element divided by atomic mass. Mass of one atom will be atomic mass divided by 6.023 divided by 10 raised to power 23. Now, how are you getting this mass of one atom? See, the calculations for this are fairly simple. Just use your logic. See, atomic mass was what? Atomic mass was mass of Na atoms, right? No. So, if I just write it like this, Na, and I write here atomic mass, if I divide both sides by Na, I'll get Na atoms here, suppose, atoms. You will get one atom here, and here you will get atomic mass by Na. Right. So that is the formula here. Same one molecule, moles of compound, mass of compound, molecular mass. This mass of one molecule, again molecular mass by the Avogadro's number. Right. Now, before I move forward, I want to give you a certain shortcut formula so that you are able to convert very easily moles to mass, mass to moles. Let us get to that. Here I keep mass. So, moles, if you want to go to mass, you should multiply it by molar mass, right? Because if you see the formula here, multiply it by molar mass, you will get the mass. So, now, if you want to go from mass to moles, you divide it by molar mass. Now, right? So that is this formula. Now this is simple. Calculate the number of moles in 49 grams of H2SO4. Actually, I have done it already, but still. So moles is equals to mass by molar mass. The mass given is 49 grams. You divide it by the molar mass. Remember, always write the units of molar mass, 98 grams per mole. This comes out to be around 0.5 moles, right? Calculate the moles in 10 grams of calcium carbonate. So the first thing you have to do is calculate the molar mass of calcium carbonate. So calcium is around 40. Add it to carbon 12, 3 into 16. If you add it up, you will get around 100 grams per mole. Right? So the moles will be 10 grams by 100 grams per mole comes out to be 0.1 moles. Right? So the next way of calculating moles is from number of particles. Means how many number of particles are given to you. Now it's not clearly written here. Let me take white ink. Right. We know that Na particles is 1 mole. Correct? I think that is clear. And what is this Na if you remember? 6.023 into 10 raised to power 23. Correct? So, so if I divide both sides by Na, divided by Na here, divided by Na here, this Na cancels out, this Na particles become 1 particle, right? And here you will get Na mole. Correct? So 1 particle has these many moles. So this means that 1 particle moles. If 1 particle has this many moles, then n particles, simply multiply this by n, both sides. If you do that, this becomes n particles and this becomes n by Na. So this is your way to calculate or move from particles to moles. So this is number of particles, right? So this is what? This is number of particles. So given number of particles and you then divide it by Avogadro's number, which is Na, gives you the number of moles, right? For this also, let me give you a trick. So on one side I will write moles, on other side I will write number of particles. Right. So if I need moles from number of particles, what I am doing? I am dividing by Na. So division by Na. But if you have to go from moles to number of particles, moles to number of particles, cross multiply this here, you will get, so this is your formula. Okay. Yeah, it just changed the color of the yellow color. This highlighter is not doing anything, right? So, okay. So, right. So a question on that. Number of atoms in number of atoms in 16 grams of helium, right? So recall, let us recall. Number of moles is given number of particles by Na, or if you have to go from moles to number of particles, what you have to do? You have to multiply it by Na, right? So my suggestion to you will be, if any question comes, just move towards mole. Calculate the moles first, and then from moles you can go to any place you like. So if I calculate the moles here, so if I calculate the moles of helium, that will be the mass of helium by molar mass of helium. Mass of helium is 16, molar mass 4 grams per mole, this is grams, right? So this will come out to be 4 moles, right? Now you have the moles. From moles you have to go to number of particles. What you will do? Yes. From moles to number of moles, see the arrow, moles to number of particles. You will multiply it by Na, right? If you multiply it by Na, then you will get it. So the number of helium atoms will be 4 into 6.023 into 10 raised to power 23. So if you calculate this, you will get the number of particles. This you can take it as a homework, right? Now, let us move on to the next part, calculation from volume of gas at STP. So if mass is given to you, you will divide it by molar mass and get the moles. If number of particles is given to you, you will divide it by the Avogadro's number Na and then you will get the moles. But if volume of a gas at standard temperature pressure, STP means standard temperature, standard temperature pressure. Standard temperature pressure simply means that some fixed temperature and some fixed pressure. Okay. So that standard temperature pressure according to the new system is 273 Kelvin, which is nothing but 0 degree Celsius, and standard pressure is 1 bar. So what we did was, we took some gas, suppose you took oxygen gas, kept it at 0 degree Celsius temperature and kept it at a pressure of 1 bar. Then it was found that the gas, 1 mole of a gas occupies 22.7 liters volume. So at standard temperature at 0 degree Celsius and at 1 bar pressure, if you have a beaker, in here if you take 1 mole of ideal gas, right, at a temperature of 273 Kelvin and at a pressure of 1 bar, then the volume of this gas or the volume occupied by this gas will be 22.7 liters, right? Now if this 1 bar, whatever this 1 bar is, 1 minute, if this 1 bar is changed to 1 atmosphere, it is the old system, then the volume changes to 22.4 liters, right? And 1 atmosphere is equals to 1.013 bar. There is a difference. That's why it happens, right? Because now here you have increased the pressure, right? From 1 atmosphere is higher than 1 bar. So when you increase the pressure, what happens? If pressure is less, the volume is this much. Increase the pressure, the volume reduces to 22.4 liters, right? Now let us move on to the logic. How do you do that? So 1 mole of gas at STP equals or occupies a volume of 22 point, not equals, is equivalent to 22.7 liters, 1 mole. Then what about if I have n moles of gas? How much volume will it occupy? Just multiply both sides by n, right? So you have n moles of gas at STP. Here also multiplied by n. Right. So this is the volume occupied by gas. Right. Now from this volume, if I want the value of n, what I can do? I can divide this volume occupied by gas by 22.7 liters. And if I do that, this gets cancelled out and then get what? I'll get the value of n. That is how you get this. Number of moles is equals to given volume at STP in liters. Remember, in liters only, divided by 22.7. Now, at this juncture, I can make another shortcut formula for you. Hello, Manoj. Thanks for tuning in. Right. The next shortcut formula we can make is, see, always and always one side will be moles, on the other side something will be there. So this is volume at STP. So one thing is clear, from volume at STP, if you want to calculate moles, just divide it by 22.7 liters. So from here, if I go here, I will divide it by 22.7 liters. And if I want to go the reverse, if I want to calculate the volume of the gas at STP, I will multiply it by 22.7 liters. Right? So I want all of you who did join us to actually join us every day for the coming sessions, starting from 4 p.m. every day till 6:30 in the evening. We'll be having sessions of transition course for the students who have just arrived in 11th standard, so that they stay ahead of their competition, right? So before I end this, there is a question. Yes, let me summarize the complete thing that we have learned. So the central theme is moles. So write that in the center. On one side, let us write mass. On the other side, I will write number of particles. Just below this, I will write volume of gas at STP. Now let us summarize the complete lecture into one slide, how we are going to move from one place to the other. If you have to move from mass to moles, you will do what? You will divide it by molar mass. If you have to go reverse, you will multiply it by molar mass. This side is up. Let us move to this side. If you want to move from moles to number of particles, well, let us move this side first. Number of particles to moles, you will divide by the Avogadro's number. But if you have to move from particles, you will multiply it by the Avogadro's number. Similarly, volume of gas at STP, if you want to find the moles, you will divide it by 22.7 liters. And see, this one is exactly coming from this part, right? Division. And if you want to go the reverse, you will multiply it by 22.7 liters. So this is the complete summary of the lecture which I have told you today. Keep at least this thing in mind and you will be sorted for most of the part in your examinations, right? This also, take it up as a homework. We'll do that, right? Now, if you like this session, right, you understood what I talked about today, then the very first thing that you have to do is join our Telegram channel, subscribe to Telegram channel, scan this QR code. There are daily updates, daily questions, many other things happening here at Sri Chaitanya Academy Telegram channel. Please scan this. And if you want to know more, to get further updates, please fill in this Google form. Someone from our side at Sri Chaitanya Academy will call you up and help you out to reach to your nearest center and help you in getting your dreams, right? So I leave you with this slide. All of you please scan both the QR codes, fill both the forms, join the channels, remain updated, right? So it is bye from my side at Sri Chaitanya Academy. Stay tuned for the next session where we are going to learn about math.